A firewall has been at the heart of IT security for a long time. And pfSense is a very popular firewall to use, not just because it's open source or because it's free, but how do you actually install pfSense and how do you configure it? Well, check out this video to find out more. Well, here we are on the pfSense website, and as you can see up here in bold, open source security. And down here, it's the world's most trusted open source network security solution. And that is what sets pfSense apart from the crowd, from the rest of the vendors out there. You're typically purchasing, some hardware that comes with a, closed proprietary solution for a firewall, and you need a support contract if you want to be able to upgrade it and so on. But with this, the good thing about this is it's an open source version and it's free. As long as you know what you're doing, you can install it on your own hardware. You can install it into a virtual machine. Entirely up to you. On the other hand, when it comes to sort of like enterprises like this, like the referencing here, wouldn't be that too surprising if they actually purchase the entire hardware anyway. And I mean, that's what pfSense does. I mean, you can actually purchase the hardware. You can go down that path if you particularly like. I mean, these days, practically everything's getting virtualized anyway, to be honest. And so typically you'd probably want to just install it onto a hypervisor like we're going to do in this video. But you've also got choices over here where you can actually buy it as a virtual appliance, through Amazon AWS, Microsoft Azure, and so on. But it's that, it's that flexibility I like, where we can download it, we can install it, however we choose. We just do our own support, basically. So what do we do for actually downloading this? Well, over here we've got a tab, which is the latest stable version. I mean, I'll include links for both, but it's easy enough to Google them. Now, in our case, it's pretty much an easy choice, really. I mean, when it comes to architecture, it's going to be this AMD 64-bit. We're not interested in this. This is the specialized hardware for pfSense. This is when you're doing it yourself, where you've got your own, Intel or AMD processor. I mean, don't be confused where it says AMD 64. It is actually talking about Intel or AMD 64. That's the only thing to point out, though, is it needs to be a 64-bit processor. And to be honest, the vast majority of computers these days are. So we've got to pick that as our architecture. Incidentally, that 2.5.0 just happens to be the latest version available at the time of release of this video, but most of the time when it comes to the installation, it's pretty much the same anyway. But just moving on here, the only other choice really is the installer, which is, what installation method do you want to use? So they're giving us options where, you can install it to a memory stick, or you've got the more common solution, which is to actually just download it as an ISO file. And that's the option I like to go with because it gives me a bit of flexibility. If I want to install this onto a physical machine, I can actually burn that ISO file to a USB memory stick, and then I've got a bootable memory stick to boot the computer from. Or, as in this case, where we're going to put it onto a virtual machine, I've just got to attach that file to the virtual machine as if it was a CD-ROM drive, and away we go. And the only other choice really after that is, well, where do you want to download it from? I mean, by default, it's New York, but there's 3 other places. For me, the closest would be Frankfurt in Germany. But to be honest, it's such a small file anyway, it doesn't really make that much difference when it comes to the download speed for me. So once I've picked all these options, it's really just a case of, clicking on the download button and away you go. And that's when we move on to the actual building the virtual machine and installing this operating system. Well, now that we've actually downloaded pfSense, or more specifically, we've downloaded the installation file, we need to install this onto a virtual machine. So as you can see, I don't actually have a virtual machine already prepared. And I'm running, VMware's ESXi here. So the process is pretty simple because all we've got to do is just tell ESXi what operating system we're going to be running on the virtual machine. It's then going to go to a template and it's going to create sort of like a bare bones virtual machine based on our choice of operating system. It doesn't really matter if you want to install it on a different vendor hypervisor. The process is basically the same. So in our case, we're just going to go to virtual machines here, and then we're going to click on the option to create or register a virtual machine. Now, we've downloaded an installation file, which means we need a completely brand new virtual machine to install into. So these two options down here, we'll just ignore them, go with the default option there. We then need to give this virtual machine an actual name. Now, it pays to keep this in sync with the real name of the actual firewall we're actually going to build, or whatever virtual machine you build. You want the name that's shown in ESXi to match what the actual host name is on the computer itself, because that makes it a lot easier to troubleshoot. But whatever I type in here isn't going to be transferred across to the operating system. That's just something to bear in mind. So we'll configure that the name of the actual host name of pfSense the same once we configure it. Now, when it comes to ESXi, you've got a choice of compatibility. So this is the hardware compatibility, and it's basically, it boils down to compatibility between multiple hypervisors. If you're running, say 2 copies of ESXi on the network, say one that's got like version 6.5, for instance, and this one here has got version 7. If I wanted to be able to transfer this virtual machine to the other server, I've got to go with whichever hypervisor is the oldest version, basically, to keep that compatibility. So in that case, I would pick ESXi 6.5, because otherwise this version 7 hardware wouldn't work on ESXi 6.5. So in my case, there's only one physical machine anyway, so it doesn't really matter, but it's just something to bear in mind. And then it just comes down to, well, what operating system are you running? So for ESXi, we've got to go for other when it comes to this guest OS family. So I'll pick that. And the reason being is that pfSense is based on FreeBSD. Now this version, it's using FreeBSD version 12. And what we downloaded was a 64-bit operating system. So we've got to go with that choice there. Next thing is obviously, where do you want to store this? So we're going to install it onto a faster NVMe drive here. And it goes off to its template, and based on those choices. And then it's come back with these answers and says, this is what I think you need. So what I'm going to do is I'm going to tweak this a bit. I'm going to add an extra processor in there. I mean, I don't really need to, but what the heck. I'm going to put both of them onto one socket, but it doesn't really matter. 2 gig for the memory. It doesn't actually need that amount of memory, but what you can do with pfSense is you can add extra packages onto it. You can make it more than just a basic firewall. So I'm just adding this in just for peace of mind now, but I can always add it in later on if I wanted to. I could increase it, I could decrease it. That's a good thing about a virtual machine, is you can reconfigure it either on the fly, or just by taking the actual virtual machine down, and then it'll boot up, and presto, you've either got more memory or suddenly less memory, depending on which direction you go in. For the hard drive, I'm just going to leave it on 8 gig. It doesn't really matter. But one thing to point out is, although this is a lab, normally what I would do, I'd be thin provisioning the actual disk to save storage space. But what I'm finding is, particularly with pfSense here, is it does have a big influence. If I tell this to thin provision the drive, it's very, very slow, I've found. Whereas if I leave it on thick provisioned, it's a lot better. So I'm just going to leave it on that. I mean, 8 gig's way more than enough, so I'm just going to leave that. I've got plenty of storage space to cover it. For the controller, I'm going to go with parallel, because that's a better controller to use. So the only thing I'll point out among all this spec that we've put in here is, while this doesn't matter to me if I overspec this virtual machine, if I was doing this on an actual cloud provider, I'd end up paying more money for hardware that I didn't need if I overspec'd it. So let's say, for example, I'd given this 8 gig of memory. If I don't need 8 gig of memory, I'll pay for 8 gig of memory regardless. Whereas with a hypervisor, if I configure this with 8 gig of memory and it doesn't use 8 gig of memory, that unused memory just stays in the pool, so it doesn't really matter. So just something to bear in mind when you're using your own hypervisor, where whereas you're using a cloud provider, yeah, costs do matter. The next thing to do is, I need an extra adapter here, on network adapter I should say. I'm going to set the first one to be the management network, the second one to be the external network. I'm just going to go over to this diagram here. The firewall that I'm building actually has 4 network segments. This is the management network. This is the external network. But to make life a bit easier, I'm not putting these interfaces in just yet. It makes it a bit easier for the initial setup, because that's all we're interested in at this stage. So we've got two interfaces. First one's management, second one's external. Next thing to do is we need to point this to an ISO file, and that's going to be the file that we downloaded. So that's this one here. Now, I've got this installed onto a local SSD drive. I do have an NFS share here, but it'll take longer to install. I mean, pfSense is a small file. You can see it's only like 500 meg in total. But it's a case of what I find is, at least in my setup anyway, it takes a long time to pull all those files through an NFS share, because they're not on the same network. They've got to go through other firewalls, and it's just basically a lot slower. So as a quick fix, basically what I'm doing is I'm just uploading the files to a local SSD drive, and it makes the whole installation process a heck of a lot quicker. So now that we've told it, what hardware we want, what ISO file to point to, we'll just click on next, gives us our summary, and then we'll click on finish. So there we go, it's built an actual virtual machine for us. So it gives us these details here. I'm just going to expand these out for now, because you'll see in a while this will become important. So we'll just turn the actual computer on. Here, voila, it's decided to undo what I did just there. But the reason I'm interested in that is because this gives us the MAC addresses. It's just for peace of mind, just so I can double check things. If I'd put in 4 network cards straight up, this would become extremely important. As it turns out, what we'll find is that pfSense will end up aligning its own network cards with ESXi. If I'd had 4 network cards, they'd be out of sync. This wouldn't be like, the first network adapter, for instance. It usually ends up as being the second. This ends up being the third, and then the other two, one becomes the first. It just gets really messy, and it's to do with using the vmxnet3 adapters apparently. But anyway, we've booted up off our ISO file, so I'm just going to go with that option to accept that agreement there. We go with the default option to install pfSense, and then what we've got to do is, well, in my case, I've got to pick a different keyboard, because up in the top right you'll see it's actually saying it's gone with a US keyboard, but I need to pick a UK keyboard. And then now that I've done that, I've actually got to tell it to continue and use that UK keyboard. Now, I've got a choice of, what to install this onto, but I'm just going to go with the default option of a BIOS boot method. I'm finding that's works better for me, at least. So we go with that. And what the actual, machine's now doing is basically, it's actually installing pfSense onto the computer. And it's, I must admit, it's a bit refreshing, because quite a lot of operating systems I come across, what they tend to do is they'll boot up, get themselves into memory, and then they'll ask you questions, and then based on all of your answers, it then installs the operating system onto your computer. Windows is slightly different in that sometimes what it does things in phases. It might ask you a series of questions, do a bit of the installation work, then it'll ask you more questions, do a bit more of the installation work. So it does it in bits and pieces, whereas what pfSense is doing is it literally installs the operating system onto the actual hard drive, and then it asks the questions. So it does take a bit of a while here, and not too long, fortunately, because it's a very small operating system anyway. So we'll just wait for that to finish, and then what it'll do is it'll ask us to basically reboot, and then we've got to answer some more questions. So it's almost finished. There we go. So it's saying it's now actually finished the installation. It's asking, do you want to open up a shell? And I'm just going to go with the default option of no. It's giving us another final chance, but no, I'm not really interested. I'm just going to go with the default option to reboot. It should be pretty quick. You might notice that when it does reboot, it doesn't really give you much time to go through the bootloader. You've got to be pretty quick if you want to go with a different option. So it's like just a few seconds if you want to do something different. Otherwise, it just boots up and that's it. So I'll just wait for this to boot up. The only thing is it might take a bit of a while for me, because I've got certain features disabled. I'm being very, very restricted on what these computers can do. But we'll just see how long that takes. Oh, there, okay, it wasn't too long. Right, so first thing it's doing is it's showing us the actual network cards it knows of, and it's actually, fortunately, it's showing us the MAC addresses. So if these were out of sync, we'd know pretty soon. But as you can see, the first network card, which it calls VMX0, lines up with our MAC address here. And the second network card, which it's calling VMX1, lines up there as well. Now what it's actually asking is, do you want to actually start configuring VLANs on this? So in our case, I don't need to do any, but sometimes what you'll have is, like in a real world environment, you'll have a firewall that's got, say, like a 10 gig interface, for example. And typically what you do is you carve that interface up into multiple VLANs, and then you've got an identical 10 gig interface as a redundant link. Now, in our case, for this lab, none of that really matters. It's all virtual anyway. And then what I've got is I've actually got 4 virtual switches here. So I don't need any VLANs. I could have done it that way. I could have just had, say, one virtual switch and split it up with multiple VLANs, but I haven't done that. I've gone for what to me is an easier approach. Each network segment is a separate virtual switch, just as if it would be a series of 4 network switches, 4 physical network switches, and 4 physical adapters in this firewall. So, like I say, I don't have to worry about VLANs here, so I'm just going to say no, I don't need to configure any. And it's now asking us which one of these interfaces is the external one, what it calls the WAN interface. Now for us, that's VMX1. So I'm just going to tell it that. And then it wants to know, well, which one's the LAN? So that's a VMX0. And then it's giving us an option to change our mind if we want to, but I don't need to, so I'll just say yes to that. And then what it does is it literally reconfigures itself based on those decisions, because if we just go back to the diagram, what it's doing basically is it's kind of like a plug and play system, really. It's kind of similar to the routers or routers, if you prefer, that you get from service providers. Usually you would plug your router into the service provider's network. It would get an IP address through DHCP off your service provider. But what it would do, it would hard code its own IP address, usually 192.168.1.1, onto its LAN interface. And then what you've got to do is plug your computer into that and either assign it an IP address within that network or get an IP address through DHCP, and then you can get management access, to your router. And then if you want to change the IP addressing, you can do that. And pfSense is doing the same sort of thing here. When we go back, it's got one IP address that it's picked up through DHCP on the WAN, and it's got one IP address that it's hard coded. Now, as far as this network's concerned, it's entirely temporary. I mean, it's a case of, although I've got a specific network here, the IP address that I've got through DHCP doesn't line up, and that's just literally because it's temporary. For the length of this video playthrough, I'm going to be using DHCP just to keep my life easier. But when I actually finish building this lab for real, I'll be hard coding all of this. So I'm just going to go back to the console because we need to do some final changes, because I mean we actually already have this this virtual machine's already built, ready to go to be able to manage this firewall, and it's already set up for this other network. So we actually have to configure the firewall to match that network. So we're just going to do that, which is option number 2, to change the IP address. So I've got to tell it it's specifically for the LAN interface. I need to change it on. So that's option number 2. And it wants to know what is the IP address. So it's 172.16.18.254. Just double check. Yep, 172.16.18.254. It wants to know how many bits have been used to make up the subnet mask. So in our case, it's 24. Is there a gateway that you need to configure on this LAN interface? Well, there isn't in this. In this network, it's just a stub network, so we don't need a gateway on this interface. Wants to know what the IPv6 interface is. Well, I'm not going to be using that, at least not at the moment. So I'll just go with the default and say, no, don't have one. And then it wants to know, do you want to actually enable a DHCP server on the LAN? So that would be useful in, if you're going to do like a plug and play approach, but we're not for this lab anyway. So I'm going to say no. So what it does, it actually disables DHCP servers. We're then being asked, do you want to revert to HTTP as the web configurator protocol? Now, with pfSense, let's go back to the diagram again. What we've been doing so far is we've been configuring this firewall through the console, but it's actually managed through a web interface. So that's the reason I've got this actual virtual machine already built. I need to be able to get access into the web server of this firewall through a web browser on that machine. And it's actually asking us the question, do we want to revert back to HTTP? But that's not a secure protocol. It doesn't make sense to do it unless you've got some particular issues. So we don't want to do that. We want to continue to use HTTPS, because if you use HTTP, anybody who can intercept that traffic can get the actual username and the password through the exchange of information between the management computer, for instance, and the actual firewall. So we definitely don't want to do that. So it's now finished making that change to the LAN, and it's actually telling us, well, if you want to go in and configure this firewall, use that URL. So I'll just hit enter to continue. And then what we're going to do now is, well, I've got to actually boot this virtual machine up. And then what I've got to do is actually log in to that IP address. So I'll just pause the video there, get my virtual machine up and running. And then once I'm ready, I'll bring you back. Well, our management computer is now up and running. So what I have to actually do now is to finish off the actual installation process through what is going to be a web wizard, basically. So I've pointed the web browser here to the actual pfSense firewall, and that's the URL that it shows you on the console. Not surprisingly, we're getting a warning about a security risk, because this is it's a self-signed certificate, but it's also a private IP address. So we'll just click on Advanced, scroll down to the bottom and just say, yeah, we'll accept that risk and continue. We'll then log in with a username of admin. Default user password is pfSense. Now, I don't have much real estate on this screen, basically, because this computer doesn't have access to the internet. So it's a case of I can't put something like VMware's open tools on there, for instance, to give me a bigger screen. So yeah, it's a bit cramped at the minute, but it'll do. Now, as you can see, it says it's got a wizard to go through, because we've got to go through this process just to finish things off, if you will. So we'll go through a process where we configure it through the console just to get that initial setup of the interfaces, and then we finish off that bare bones installation, if you will, through this web browser. So first thing it's saying is, yeah, just welcome. So just click on next. It's just telling us about an opportunity for 24/7 support. Let's click on next. Now, here's where we start making the changes. So by default, this is going to be called, pfSense, which kind of makes sense really, but I'm going to change it over to FW. Domain, it's set for home.arbor. I'm just going to call it something else. Templab.lan is what I've called it before, for instance. I'll just go with that. Now, the primary DNS server, in my case, it's going to be, well, I've already configured this during my trials for this pfSense on ESXi. You see, I've already used an IP address of 172.16.17.10, for instance. Now, that references this DNS server over here. It doesn't exist yet, but once it's up and running, the idea is this machine, in fact, all machines, what they'll do is they'll come to this server as their DNS server, and this will act as a DNS forwarder to be able to get DNS resolution to the internet, for instance, or to resolve any DNS names within the actual lab itself. So at the moment, I'm well aware that that server's not up and running, but we're going to configure it all the same. Saves me coming back to it later, because it's not particularly important now. I just need to get the firewall up and running, and then I can start building my servers afterwards. So one thing to point out is down here, it's actually set to this setting where it says override DNS, and that's ticked. And it's saying allow DNS servers to be overridden by DHCP/PPP on the WAN. What that means is if you're running DHCP on the WAN interface, which by default you are, any DNS servers that this firewall learns through DHCP will override whatever you put here. Now, I've put in one IP address as my primary DNS server. I haven't put anything in as a secondary because I only have the one DNS server. But it's a case of whatever I put in is going to get overridden by whatever this firewall gets, from DHCP anyway. So I'm going to untick that box because I want to force everything to a specific DNS server. I want to have control over DNS resolution. So we've deselected that, and then move on to the next step. So we're up to step 3 now. So it wants us to set, where we're going to get our time from, because it's going to sync itself using NTP to, well, by default, a server called 2.pfSense.pool.ntp.org. We can change that to something else. I mean, it's a publicly available NTP option. If you go to ntp.org, it'll give you a big laundry list basically of servers or pools that you can point to, but I'm just going to leave that there for now. Time zone, for me, actually, ETC/UTC would actually work, but what I'm going to do though is I'm still just going to change it. I'm going to point it to Europe/London. So you just set that to whatever whatever your time zone happens to be. Change the the time server pool name if you want. It's entirely up to you. But NTP is extremely crucial, not just for network devices in general, because that helps in troubleshooting. So, for instance, if the clock on a computer is out of sync, say you get a phone call 2 o'clock in the morning, somebody's reporting a problem. If the clock's out of sync on the computer that is having the issue, it's going to be a lot harder to look in the logs and equate any faults against the time. So you definitely want NTP to be in sync. Definitely crucial for firewalls because of security reasons. You want to know, when somebody was trying to hack something, when somebody was up to strange behavior, doing up to no good and so on. That is something hackers tend to do, is they'll play around with the time if they can. They'll try to erase logs and so on. So you might be able to see, somebody cleared the logs at this certain time of the day and so on. You can spot patterns, all that sort of stuff. But another reason is there are features out there, things like VPNs, I believe, where they can be very, very fussy if the clocks are out of sync. So getting everybody synced up to NTPs, everybody's in agreement, definitely crucial. So do make sure you're allowing access to NTP, whether it's an NTP service that you're running on your own network or whether it's a public internet one. Make sure you're getting NTP and that these computers are actually up to date with their clock. So that's step 3. So just click on next, and now it's wanting to know, well, it's actually giving us the option to change what we're going to do for the configuration of these interfaces. Now, I did mention before that for my real lab, once I actually rebuild all this will all get hard coded, and that's something you definitely want to be doing on a firewall. In this case, for the sake of this video series, I'm just going to leave it on DHCP. It's just going to make my life a bit easier. So I'm not going to change anything, but that's what it's giving us the choice to do. I mean, there's all sorts of PPP over Ethernet options, PPTP options. These are all usually associated with WAN links and so on, which they don't apply to us. One thing I'll point out though is because this is a firewall which is on an actual private network and it's actually behind an actual private network, I want to disable these options because it's going to have to communicate with computers that are in private networks. If this was on the public internet, if this WAN interface was the public interface, I would leave those ticked, because what it does, it stops computers with a private IP address trying to get access into your network. These sort of things shouldn't be happening on a service provider. Your service provider should be blocking private IP addressing across the internet. They should stop you sending traffic out with a private IP address. They should stop any private IP addressing coming towards you. There's all these other networks that are technically public. They're not part of like RFC19, for instance, but they are reserved IP address ranges, so those shouldn't be on the internet either. So in our case, as I say, because we're sitting or hiding behind an actual private network and not actually touching the actual public internet directly, even though the diagram might imply otherwise, I want to disable that, otherwise things just will not work. So click next. Next step is, it's asking us basically the same, do you want to change your mind for the LAN interface? So this is an opportunity, like I was saying before, where basically what the firewall is doing is being plug and play. We're going to get everything through DHCP on this because we assume you plug into the ISP. We're going to start off with an IP address of 192.168.1.1, but you can change your mind if later on if you like. In our case, we've already did that whilst we're on the console, so I can just leave that as is. So next is change the password. Now you might have noticed it's been complaining about the password right from the get-go. So I do need to put a different password in. Now you really want to put in a much stronger password that I'm going to use, much longer one, more complicated. But because it's just a video that a series that I'm doing, and this is just going to be short-lived, it doesn't really matter. It just makes my life easier for getting these configurations done. So change the password. Good, I did get it right. Right, so we're now up to step 7, so I'll just click on reload. So it's taking those changes on board that it's picked up through the wizard, and then it's reloading itself. So there you go. It's saying, oh, step 8 was pretty much the actual reload. Step 9 is just gentle reminder, you can get 24/7 support. There's a server here if you want to do it, but in our case, not too fussed about that, we're done. So that's it. So that's the actual wizard finished. So it's just going to finish off, and then it'll give us an actual dashboard where we can actually start configuring things from. Because one thing I'll point out is what this firewall does. It does go in some way to make things a bit more secure, and that it doesn't put any firewall rules on this external interface. And what that means is you get what's called an implicit deny rule, where basically any traffic that comes into this interface, into the firewall, will be dropped. And that's, as I say, through what it refers to as an implicit denial rule. You don't see a rule, but it's sitting there in the background dropping traffic. On the internal interface, on the other hand, it's what it's done is actually set up an interface rule, or 3 rules actually. One, what it does is it allows anything on this network to get management access to the firewall. It's actually a fallback option, so even if you really mess up the firewall rules, you'll still be able to get management access to the firewall. But it's also got 2 other rules, one for IP version 4 and one for IPv6, which allows any traffic into the firewall. Now, from a plug and play perspective, that's great. It makes your life easier. From a security perspective, it's terrible. The mantra for security for a long time now has been assume somebody is on your network, or your network has been hacked. That's been known of for a long time. So the one thing you do not want to do is allow any traffic through an interface. You want to be operating on least privilege. So for example, say this computer here, it needs management access to that firewall. So we need a rule that allows management access from this computer to this firewall. It also needs DNS access to that server over there. So we need a rule for that. It probably needs, HTTPS access out to the internet. So we'll need a rule for that. But that's it. We want to block every other type of traffic coming from this computer or the entire network in its entirety. We want to be making sure we're making things as difficult as possible, because the security is a bit of a cat and mouse game. Sometimes you win, sometimes you lose. It's a case of trying to set up an onion ring of security layers to make it as difficult as you possibly can. If someone is determined enough, they'll probably just even bypass your security process through social engineering or something, or some user will click on a link and next thing you know, you've got malware on your computer. Somebody might just get paid off and bribed. You name it, there are ways of getting around whatever security you put in place. So you just make it as difficult as you possibly can, and that is one thing you definitely want to be doing, because there are tools out there that have been known of for a long time. They've been available and are still available, where they use internet relay chat, for example. So by default, if somebody had planted some malware on this computer that was using internet relay chat, it would be able to get direct access out to the server out there on the internet, and this little botnet can do whatever it's being told to through internet relay chat. Because we're going to put in more restrictive rules here, we'll stop that sort of thing from going on. Yes, we're allowing HTTPS access out to the internet. Any clever attacker's going to make sure that that's the protocol they use, but it's a case of there are a lot of tools that don't do that, so make sure you block them. When it comes to things like HTTPS, you'd go with more sophisticated security solutions where, yes, the firewall allows them. We allow HTTPS through the firewall, but you've got something else that actually inspects that traffic. So you'd probably have like a proxy server doing content inspection, it would actually decrypt that sort of traffic, and it'll check it and see if it's legitimate. Make sure it's not going to websites it's not allowed to, make sure it's not up to no good. In our case, it's just a lab, so that's pretty much the best I can do, or at least for now. So just go back and see if that's done. Yep, it's done. So it's just going through the licensing details up there. So just click on accept up there. Yep, thank you note from them. And here we are at the dashboard. Now, like I was saying before, the issue that I've got is I don't have something like, VMware's tools on here to make the screen bigger, because the computer doesn't have access to the internet yet. But this is the bare bones dashboard. It's not really up to much. I mean, disk space usage so far is 18%, memory utilization 12% out of 2 gig, CPU utilization diddly squat. But to be fair, the firewall's not really doing anything anyway. So what we're going to do is I'm going to make some changes, because if we go over to the rules, for example, I'll show you what I was talking about. So we've only got 2 interfaces, and you can see here it's showing we've got one called WAN, one called LAN. You've also got this one called floating. Now, what you've got are options here. Floating rules are rules that apply to all interfaces, but these interface rules trump these floating rules. So if I put a rule on as a floating rule that blocks access to something, but say there's a rule on the LAN interface that allows it, well, that one on the LAN interface takes precedence anyway. So there's only certain types of rules you end up putting onto a floating rule as opposed to the interface. So most of the time I just set up the actual LAN rule, the LAN and WAN rules, for example. Now, one of the first things I want to do is to actually change these rules. So you've got choices here. You can add a rule at the top of the list, or you can add a rule at the bottom of the list. One thing you can't do is add a rule in between existing rules, which is a bit of a pain. You can drag them around, but I'll show you what I mean as we go through it. And then what I'll do is I'll show you like a completed set of rules that I can think of at this moment of time that might come in useful. So I'm just going to click on that. What I actually want for this WAN interface is I actually want to block. I want to put an explicit block for traffic on this interface. So I'm going to block IPv4. Well, I'm going to stick to IPv4 for now, because I know there's no IPv6 out there anyway. But I'm going to block any protocol, because IP is a suite of protocols. I want to block all IP traffic. I don't care where it's coming from. I don't care where it's going to. But I do want to log it as well. So I'm just going to put that description there. I'm just going to say, yeah, explicit deny rule. So as you can see, been there, done that, and it's remembered it on the browser. So I'll just click save. So you can see there's a rule there. It's telling us, the protocol is IPv4, everything else is a wildcard. So it's any source, any protocol, any port, any destination, and so on. But the thing is, although the rule's been created, it's not actually applied. So we'll click on that apply button, and now it's actually applied. Just go back to the rules. Now, if we go back to the LAN interface, this is what I was talking about before. We've got what's called an anti-lockout rule. That's sitting at the top. You can't delete it from here. You've got to go into the system to remove it. And it's effectively allowing any device on this network that's been called LAN to get access to port 443 or port 80 in order to get management access to the firewall. So that's the reason it's called an anti-lockout. It's to stop you basically locking yourself out of the firewall, because if you can't get into the firewall, you're basically stuck. So what I've got to do is I've got to come up with a series of rules. I don't like this, where it's allowing all IPv4 into the firewall and all IPv6. That to me is just nuts from a security point of view. Makes sense probably from plug and play, but it's not a good idea. So what I want to do is I want to add a series of rules. So for example, I want to, what I'll do is I'm going to set up a rule for DNS, for example, just to give you an example. So I've got one here. It says we're on the LAN interface. It's IPv4. Protocol is UDP. Now the source, I actually want it to be the LAN network. So it saves me having to specify what the actual IP ranges is, for example, because this rule is going to apply to any computer that's got an IP address in the range 172.16.18.0/24 that's coming in on that interface. And I'm being very specific. I'm not saying allow any. I'm being very specific because it stops spoofing, for example. I mean, technically you wouldn't be able to get access to the DNS server as such. Well, in the case of UDP, you'd be able to send requests to the actual DNS server if you were spoofing IP addressing, but it's a case of, well, if your IP address isn't in that range anyway, the firewall, it's not going to get sent directly to the firewall anyway. It's going to get a bit confusing, but it's still better from a security perspective to be very, very specific in terms of source ranges. Now, destination, I need to be much more specific about that. At the moment, I'm just going to leave it as any, because what I'm going to do is I'll show you how you can actually set up hosts. I mean, what I could do here, I can actually go to this option here, which is single host or alias, and I can start putting in an IP address. But what I can do is set up what are called aliases, and that'll make my life easier. So for now, I'm just going to leave that set to any. I'm going to set the actual port to be 53. When you select one of these pre-built application ports, it automatically mirrors it to the port over on that one anyway, so that's fine, because that's to do with the range of ports you're going to use. I don't need to keep an eye on this traffic, so I don't need to log it. I'm just going to change this description to allow DNS, for example. Click on save. Again, although we've got a rule, which is here, if you notice, I clicked on the option there, which is to add it to the top of the list. That rule basically trumps everything. It's always going to be at the top of the list. It has to be to prevent yourself being locked out. But it's a case of this rule, although I've configured it, it hasn't been applied yet. So I'm just going to click on apply. And then that's now in effect. But what I'm going to do is I'm going to create an alias first to make this a lot more specific, because that's what you want to do. You want to be, using least privilege here. You want to be as very specific as you possibly can. Now, I've come over to here, which was probably jumped a bit too quick. If you go to Firewall here, from the drop-down option there, you've got aliases. At the moment, it's empty. So what I can do is I can add aliases for IPs, ports, and URLs. I'm going to click on add. Now, what I can do here is I could set up a kind of like a host name, or I can set this up as a group of IP addresses, for example. So I'm going to call this one DNS servers, because at the moment in this diagram we've only got one DNS server, but over time we might expand things. I might change IP addressing, who knows. By setting up a kind of an overarching name called DNS servers, it's just a list of DNS servers. So it gives me a lot of flexibility and saves me having to do a lot of changes further down the line. Now, I could put a description in if I like, but I'm basing it on the actual name to be the clue there. I've got choices in terms of the types. I can have hosts, I can have networks, for example. In this case, it's specific hosts, and this is going to be 172.16. I think it's 17.10. Let me just double check. 172.16.17.10. Yep, so I'll just save that. I'll apply the changes. So technically there's only one device here, but because the name has no real reference to that, that's not a host name, that's been related to the actual IP address. This, to me, it's just going to be potentially a group, because I can go back into here and I can add another entry. For instance, I can say, all right, I've got another server called 172.16.17.11, for example. I could add that in. So hence why I'm saying this has the potential to be an actual group versus a specific host. But we've done that anyway. I'm not too fussed now. At the moment, I only need to reference one specific DNS server. I'm going back to the rules again. We'll go back to the LAN interface, and what I can do is I can change this rule and I can make it more specific. So I'll edit that rule, and what I can do is, where at the moment we're pointing to a destination of any, I'll change it over to single host or alias. Now the actual parser here is actually quite clever, because as soon as I start typing, it's going to associate that with an alias. So I've just got to click it. And it's not because I've actually used that name in a previous build or anything. It's just the fact it's actually parsing. It knows that there's an alias out there called DNS servers. So this is making this this rule much more specific. So again, we've got to apply the changes for that to take effect. So now what we've got, instead of a rule that's pointing to any DNS server out there, it's actually pointing to an alias which is being translated to 172.16.17.10. But the good thing about this is that if I wanted to make a change, I don't have to change the rule itself. All I've got to do is update the actual alias entry. And that makes life a lot easier, makes things a lot more simpler. It's also less riskier, shall we say. There's less chance of something go wrong if I just keep adding servers to this list versus having to edit the actual rule itself. There's less chances of something going wrong then. So yeah, trying to do a bit of forward thinking when it comes to creating rules like this. But I mean, the good thing with pfSense though, I mean, as I was saying, although you've got this choice of either adding a rule at the top or the bottom, you can actually grab a hold of a rule, for instance, and drag them. So I can drag that rule above that rule, for instance, or I can drag that one above that one. I can never go above that one because it's an inbuilt rule. It's built into the system. So I've only got the flexibility of these 3 rules that we've got now. But all this needs changing. So what I'm going to do, I'm just going to click save. Technically, I didn't really move it at all, but the fact that I was moving things around as far as it's concerned, you changed something. So anyway, what I'm going to do is I'm just going to update all this, just flesh it out a bit more. And then once I've done that, I'll come back and we'll pick up from there. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.